Today we want to make a little different video from what we have been doing on the channel. What we want to do today is to see what happens when we have an ice that is floating on a glass of water. Okay, we want to know or to find out if the ice melts, will this make the level of the water rise? Well, that is what we are going to show. Okay, so first of all, I have divided, well, the volume of the ice in two pieces. The volume that is out of the water and the volume that is inside the water. Okay, this ice is floating on a glass of water, so we have a piece of volume that is inside the water, the volume that is in red. So what we can say at the beginning is that the total volume of the ice is going to be V, and it's going to be the sum of V out plus V in. Okay, I think this is a pretty obvious relation, so there is no too much problem there. So another thing that we can say is that the weight of the ice, let's say it is W, well, it's going to be equal to the density of the ice times, well, the volume of the ice, which is B, times the acceleration due to the gravity. Okay, so we have our first equation, our first important equation. Now what we are going to use is the Archimedes Principle. And what does it say? Well, remember that Archimedes says that if we have an object that is floating on water, well, this object has a weight, okay? And also this object, well, it has displaced some volume of water, okay, that is equal to the volume of the ice that is inside the water, okay? This volume here, well, it's a volume of water that were displaced, okay? And that volume has a weight, okay? We are also going to have a force that is known as thrust force, okay? And, well, that will be a force that is acting on the ice cube, okay? And that force, well, is going to be equal to the weight of the volume that was displaced, the volume of water that was displaced. Okay, so that weight, the weight of the volume that was displaced, okay, is going to be equal to, well, the density of water times the volume, which is V in, times G. Okay, and what the Archimedes principle says is that, well, these two are equal, okay? Remember that this is the weight of the ice, and this is the weight of the water that was displaced by the ice cube, okay? So what happens if we equal these equations? Well, we are going to get that the density of the ice times the volume of the ice times the gravity is equal to the density of the water times the volume displaced, which is V in, times the gravity. We cancel the g's, and we get that that volume that was displaced is equal to the density of the ice over the density of the water times the total volume of the ice cube. Okay, this will be a very important result. And another thing that we know, well, is that, well, the mass needs to be conserved. Okay, the mass is not going to change. So that means that, well, the mass of the ice is equal to, well, the density of the ice times the total volume of the ice cube. And then, well, the mass of the ice is also going to be equal to the density of the water times a volume, after the melt, okay? Let's say that that volume is going to be named as V0. Okay, that is the volume that the ice cube gets after it is melted. Okay, so when it becomes water, well, it now has a new volume which we are going to name as V0. Okay, so looking at, well, the mass of the ice is going to be equal to the mass of the water after the melt. Well, we can set these two equations to be equal, and then we get that the density of the ice times B is equal to the density of the water times B0. Okay, and that we can solve for B, and we get that this is the density of the water over the density of the ice times the volume of the ice melted, V0. Okay, so we can easily take this expression and plug it into this equation that we found first to get that V in is equal to the density of the ice over the density of the water times the density of the water over the density of the ice times V0. And we easily see that V in is equal to V0. Okay, so that means that, well, this volume in red that I have here, that is the volume of the ice that is inside the water at the beginning, well, it is equal to the volume of the water after the ice is melted. Okay, so that means that, well, the volume of, or the level of the water, it doesn't increase. Okay, because all this volume, yeah, it will become all this volume here. That is what we just showed on this equation. Okay, so that means that the level of the water will not change, looking that there is no increase on the volume of the, well, the water that is on the glass. Okay, so that means that, well, if the ice melts, well, the level of the water will not increase.